Okay, we're on problem number 4. They say it's a second order, so I'll go to the whiteboard and take their hint that it's second order. So let me do that. And what's S? I'll write this down for you. S is equal to, well, let's type it's 5 minus 13x plus 35x squared minus 97x cubed, and then plus 275 x4 plus yada, yada, yada. I'm going to multiply S by AX, and I'm going to multiply S by BX squared, second order. Let's see what you get. You're going to get plus 5AX minus 13AX squared plus 35AX cubed minus 97AX4 plus yada, yada, yada. All right? Now let's do the BX squared. What are you going to get? Plus 5BX squared minus 13BX cubed plus 35BX4 plus yada, yada, yada. Again, the hope is that every term here outward is going to disappear. All right? So let's just add things together and see what happens. So what are you going to get? You're going to get S1 plus AX plus BX squared equals 5 minus 13x plus 5AX. All right? Again, the hope is that this is going to disappear, this is going to disappear, and so forth and so on. All right? Now, I said second order, so I'm just going to trust them on it. So let's take a look at this. So what would this mean for me? It would mean that 35 minus 13a plus 5b would have to equal 0. And the next one would be minus 97 plus 35a and minus 13b would be equal to 0. All right, it looks a little difficult, I'll be honest with you. But let's give it a shot. And I'm going to... Boy, it looks like a deja vu all over again, doesn't it? I'm going to multiply the top equation by 13 and the bottom equation by 5. And let's see what we get there. Again, please feel free to use a calculator if you're struggling, all right? Or if you're tired, all right? So 13 times 35 is, let me write this down, that's 350. And 3 times 35 is 105. So that's going to be 455. Minus, well, 13 times 13 is 169a. And then you're going to get, well, 13 times 5 is, let's see, 65b. That equals 0. And now 5 times minus 97, let's see, that's 450 and 35, so minus 485. And then 5 times 35, 150 and 25, 175. A, and then, minus 5 times, 5 times minus 13 is minus 65B. You're going to add these together, and what do you get there? It looks like you get 30. And then you're going to get 6A, and then you're going to get no B's equals 0. So A has to be, let me show if I did that right. Oh, I'm sorry, this is minus 30. Let me make sure I'm doing this right. Minus 30. Yeah. So A has to be 5. All right? So then the question comes, how are you going to get the B? And let me go through that with you. I need to pick one of these. And the one I'm going to pick, again, it's like a toss-up, but I'm going to pick this one here. And let's write this down. So it's going to be 35. Whoops. It's going to be 35 minus, well, if A is 5, that's going to be 65, plus 5B equals 0. I'm going to get minus 30 plus 5B is equal to 0. So b would have to be 6 then, right? All right, so we're certainly at a milestone now. And I want to write down what the milestone is. The milestone we're at is, and again, maybe I should outline that for you. We're at this milestone right over here. And I'm going to write that down now, all right? So I'm going to write down s is equal to, this is the fraction, that's what they want us to come up with. It's going to be, let's see, 5, well, a is 5, right? So what do you get? You get minus 13 plus 25, which is going to be plus 12. And what do you get on bottom? Well, you're going to get 1 plus a, that's 5x, plus b, and that's going to be 6x squared. I'm going to use partial fractions with the assumption that I can handle it. Now, I know that I tell you that we're done with the a and b up here. When I put a and b over here, they're different a and b now. They're not the same ones. They could be the same, but I'm saying they're not the same. All right? So let's take a look. I'm working on this problem now. And I got to write down what do I got here? I got 1 plus 3x, and then I get 1 plus 2x. I got to check that to make sure that's true, by the way. So you get 1, you definitely get 6x squared in the end, and you get 5x in the middle. Looks good. Multiply both sides by the LCD. This is partial fraction decomposition. And then what do you get? You get plus b, 1 plus 3x. So I'm going to pick a nice easy x for me, and I'm going to pick x to be minus 1/2. And what would you get there? You would get 5 minus 6, which is minus 1. 1 plus, 2 times minus is minus 1, that's 0. And then what do you get for b? Let's write this over here. It's a little more complicated. It's going to be 1 minus 3/2, which is going to be b. That's going to be minus 1/2. So b would have to be equal to 2. All right, let's keep going. I'm going to pick another easy one. And let's do that. Let's pick x to be, I'm going to pick 0 this time. That's going to be 5 on the left side. And let's see, you would just get a plus the b, which is 2. And, 1 plus none is just 1. So what do I get for a? Fairly simple. A would have to be 3. So I'm ready to put that in now. I'll get my eraser out. So the a is 3. And the b, let's get my eraser out over here, is 2. All right, this is another milestone to meet, and it's an important milestone to meet because it's going to allow you to move forward. So I get 3 over 1 plus 3x. I get 2 over 1 plus 2x. And really, the series that we're using is a very simple one. We're using this one over here. And this would be 1 plus u squared plus yada, 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 with the understanding that the absolute value of u is less than 1, or use a proper fraction. So I got to do that now, right? So what are you going to get? S is equal. And I'm going to concentrate on one at a time. So it's going to be 3 for the first term. 1 plus minus 3 to the first power plus minus 3x to the second power minus 3x to the third power. I think you get the idea. Yada, yada, yada. And then what do I get? Oops, I don't lose track of this. Plus 2, and that's going to be expanded. 1 plus minus 2x plus minus 2x squared plus minus 2x cubed plus yada, yada, yada. All right? So I think I could start writing things down. I'm going to do something a little strange over here. I'm going to erase these things over here and put down minus 3x to the 0 and minus 2x to the 0. All right, I'm going to write the sum down now for you. And the sum, let's write this over here. I'm going to start at 0. I'll say j is 0 to infinity. And it's going to be 3, all right, times minus 3x to the j. We'll get the x later, by the way. Oh, no, the x there. I'm sorry. I didn't say the x is there. Plus 2 to the minus 2x j. All right, that's not bad looking. Now, of course, I'm going to try to figure this thing out a little bit better than that, because it just doesn't look right to me. And again, this is S. This is S. So I'm going to say, let's see. I got to be careful here, right? So I definitely see an alternating pattern. I'll just put this as minus 1 to the j. I got that covered. And then it's going to be 3 to the j plus 1 times x to the j. Let's put the next one down. That's going to be minus 1. Whoops, I'm sorry, plus minus 1 to the j. I see that. And then I see 2 to the j plus 1 and x to the j. Again, it just doesn't look right. I'm going to keep working on it. I know they didn't ask for this, but this is helpful if you want to learn that. Let's take a look. Minus 1 to the j, x to the j. I got this covered. 3 to the j plus 1 plus 2 to the j plus 1. All right? I'm going to clean up a little bit more. I'm going to combine these two together now. I'm going to try to make it as compact as possible. All right. Let's write it down then. AN is equal to 3 to the j plus 1 plus 2 to the j plus 1. I'm sorry, I'm using j when he's used n. Sorry about that. I do that often. And that's considering you're going to start at 0 and move forward. But you know, Wells likes to start at 1, so let's put this over here, AN. And if you're going to start at 1, it would be 3 to the n plus 2 to the n minus x to the n minus 1, and that means we're going to start at 1 and we're going to move our way forward. So this is what Wells wants. He wants to start at 1. We're going to start at 1. Now let's go back to the series. Yeah, I know it's a lot of work. And I think I did this over here, remember? And which one's most restrictive? This one over here. So what does it mean? The absolute value of 3x less than 1, which means 3x is between 1 and minus 1, which means you got minus 1/3 x and 1/3. All right? And let's write that down. So now this is true if the x is between minus 1/3 and 1/3. Right? What I'm going to do is just look at the answer key now and see if we got it. And sometimes, you know, you might be confused that you don't get something. Sometimes you look at it, right? So I got AN written down equals 3 to the n plus 2 to the n minus x to the n minus 1. And again, Wells is starting at 1, and I have this over here. They wrote it a little differently. They wrote it this way over here, which is the same meaning, by the way. This and this are identical. All right? All right, we're done. Thank you.